Welcome to New Focused Approach to Mathematics Basic 9. This is the revised edition. And this lesson, we want to look at how to represent complement of sets using diagrams. This lesson can be found in page 12 of your textbook. Now, we know what complement of sets is. We've learned this already, but we can still go over it again. The complement of sets, we said, is the set of elements in the universal set that are not in the original set. They are the universal set, but not in the original set. For example, if I define the universal set to be a set of numbers containing, or a set of numbers 1, 2, 3, 4, 5, 6. Let's end here. Okay, this is the universal set. And I define a set called set A, and set A has elements 3, 4, 5, 6. Okay. Now, when it say complement of set A, what we are trying to say is that, okay, what are the elements in the universal set but not in the set A? And you can see that we have 1, 2. Okay, these are the two elements that can be found in the universal set but not in the set A. And so we call this set complement of the set A. That is what we are trying to say. Now, how do you represent this using Venn diagram? Let's say we have set A like this. Okay, or before then, let's say the universal set, that is the element 1, 2, 3, 4, 5, 6, is represented by the rectangle. Okay, and then set A is a subset of the universal. Okay, and so this is what we have. So set A is inside the rectangle, that is representing the set A inside the set U, or the universal set. Now, the complement of set A are all the elements that are outside the set A, but then they are inside the universal set. That is what you represent as the A complement. So diagrammatically, we can use this to represent the complement. So the complement of set represents all the elements that are outside the set, the original set A. Good. Now let's take another example and see. Let's say we have universal set to be this, and set A is defined and set B is defined as that. Now the question wants us to find the complement of A. So I can start by saying complement of A will be equal to all the elements that are in the universal but not in A. So that can be 5, 6, so 5, 6, 7, 8, 9, right? Okay. Then let's say B, complement of B. Also, we are looking at B. So B is 2, 4, 6, 8. So the complement is going to be 1, 3, 5, 7, and 9. So these are the complement of B. And now the question wants us to find A union B complement. A union B complement. And A union B complement will be, okay, so A, we know A to be this, and union B complement, that means we write all the elements of A, 1, 2, 3, 4, and then B complement is this one. So 1 is already here, 3 is here, so 5, 7, and 9. So that becomes the union of A union B complement. Then finally, we want to find A complement intersection B complement. So A complement is here, B complement is here. The intersection of these two sets, we can see 5 appearing in both sides. We can see 7 appearing in both sides, and we can see 9 also appearing in both sides. So that represents A complement intersection B complement, right? So that is that. This same question can be answered using the Venn diagram, okay, using the diagram. So what we are going to do is that we have to represent all this information that we have here on the Venn diagram. First of all, let's see whether we have an intersection between A and B. And A and B, yes, we have, because you can see that A intersection B will give us 2 and 4. So A intersection B is 2 and 4. So we first have to represent 2 and 4 in the intersection position. Now, after doing that, what is left in A? What are the elements left in A? The element left in A will be 1, okay, and 3. Then the element left for B, after representing 2 and 4 in the intersection position, we have 6 and then we have 8. So then I can see that if you pick the whole of A, we have 1, 2, 3, 4. And if you pick the whole circle of B, also that's the whole circle of B, we have 2, 4, 6, and 8. Right. So that for now. Okay. So now, do we have other elements that are outside A and B, or elements that are in the inverse but not found in A and B? So we can see that looking at the universal set again, we can see that 1 has been represented here already, so we can write 1. 2 is also here, 3 is represented, 4 is represented, 5 is not, so we can put 5 outside the 2 circles. 6 is represented, 7 is not, so we can put 7 outside, and then 8 is there, 9 is not. So now this is how we can represent the information like the universal, the A and B on the Venn diagram. Now, based on this Venn diagram, we can answer all other questions that we've already answered, like what is A complement? That means you look at outside A, all elements that are outside A become A complement, like 5, 6, 7, 8, and 9 become A complement. Then the B complement also becomes all elements that are outside B, which will be 1, 3, 5, 7, and 9, like we did. Then if you want to find A union B complement, then that one to elements that are in A, which is 1, 2, 3, 4, union elements that are outside A, which is 1, 3, 5, 7, and 9. I mean, so we can do this and answer the same question. I'm sure this really has helped you to understand the concept of complement and how to represent it using Venn diagram. Thanks so much for watching.